Welcome to our generic talk show. Please welcome in our host, Generic White Man.
Thank you. Welcome everybody. Today we have a very interesting guest interview, one that not only contributed to the field of math and science, but also other interesting fields like astrology. So let's please give a warm welcome to Sir Isaac Newton. I think you have the wrong person. I'm not. Why don't we start with your upbringing? How were you raised? Wait, you said he contributed to astrology? He contributed to astronomy, not the things white millennials obsess over. Alright, sir, what was your upbringing like? It says here that you gave us 3 laws of motion, but so far all you're giving me is an attitude. Well, Isaac was born in Woolsthorpe, England to his parents. British? Ew. Anyways, he was born to his parents, Hannah and Isaac, and as you can tell, he was named after his father, Isaac. He attended Trinity College in Cambridge, where he studied mathematics, optics, and physics, and his work since graduation has not only transformed the way we understand the natural world, but have also had a profound impact on modern science. That's kind of cool, but why should I care? I mean, it's not like his discoveries are important to me or impact how I live. They do, though. Without Newton and other scientists of that time, we wouldn't have a lot of the technology we take for granted today. Newton was a very bright and interesting individual. He was very smart, and we can credit him for many things we have today. Can you please expand on your laws of motion for us? Do it in an interesting way. Our audience isn't very bright. I can, but I feel like you still think I'm Isaac Newton. I'm not actually him. He died close to 300 years ago. Alright, let's go step by step. Newton's first law of motion, also known as the law of inertia, states that an object at rest will remain at rest and an object in motion will remain in motion with a constant speed unless acted upon by an external force. In other words, objects tend to maintain their state of motion whether it is at rest or in motion unless some external force acts upon them. This law is fundamental to understanding the behavior of all physical systems, from the motion of planets and galaxies to the behavior of subatomic particles. That's kind of obvious, don't you think? What do you mean? Well, it's pretty obvious that when things move, they have a force put on them, and when they don't, they haven't. Why did we need you to tell us that? I think you're very much overestimating how smart people were back then, and even without that, it's helpful to have specifics and equations for people to use for other things. His contributions have helped us understand more modern ideas, like why one's body moves to the side when a car makes a sharp turn. If you say so. How about your second law? And please, when you describe it, make it more interesting. Sorry, am I boring you? Yes, you are actually. Please be more interesting and or funny. Alright, well, Newton's second law states that the acceleration of an object is directly proportional to the force acting upon it, and inversely proportional to its mass. In other words, the greater the force applied to an object, the greater the acceleration, and the greater the object's mass, the smaller the acceleration. Sorry, you were boring me. Alright, here's a more simplified and interesting way to understand it. Newton's second law says that how hard you need to push or pull on something depends on how heavy it is. His second law of motion is all about how things move. It tells us that when you try to move something heavy, like a big rock, you need to push or pull really hard to get it moving. The bigger the rock, the harder you need to push or pull to make it move. But if you're trying to move something light, like a feather, you don't need to push or pull as hard to get it moving. That's because it doesn't have as much stuff in it, or as much mass as the big rock does. Oh, I get it. So if I'm like trying to move my phone across a flat surface, you're saying that the weight determines how much I have to push on it? Yes, exactly. Would you like me to describe the third law in a similar way? I was just gonna ask you to do that. Alright, well, Newton's third law is all about how every action has an equal and opposite reaction. Have you ever played a game of tug of war with other people? When you pull on the rope, your friend pulls back with the same force, right? This is kind of like Newton's third law of motion. It's like when you jump on a trampoline. The trampoline pushes you up with the same force that you push down on it. Or when you throw a ball against the wall pushes back on the ball with the same force, which makes the ball bounce back to you. It's like a game of push and pull where everything has to balance out. That makes a lot of sense. If only my science teachers taught me like that. Well, they're just doing their job. It's a little unfair to blame them. Yeah, I'm not smart anyway, so it's hard for me to understand. Is that all you wanted to ask about today? Yep, thanks for joining us, Isaac. I'm not Isaac Newton. My name is George. What? Get out of my studio! The Generic Talk Show is filmed in front of a live studio audience.